In 1980, something strange came to the Earth. Something which would change things forever.
Yeah, that's quite enough of that. Let's do it the other way. Lithium-ion cell technology has been around since 1980 and it's changing the world. Let's have a look at why. They get their name from their size. But what makes lithium cell technology a game changer are the other numbers. 15.5 amps from a cell this size would previously have sounded ridiculous. And one of these tiny cells can provide 3.5 amps continuously for more than an hour. At a nominal 4 volts, that's about 12 watts for an hour. Ridiculous for a cell of this size. However, just like dynamite, with all this power comes danger. If you draw too much current, perhaps by shorting out the cell, it will get very hot, vent gas and may catch fire. And if you overcharge it or undercharge it or allow it to get too hot, you might destroy it. But let's set those concerns aside for a moment and see how we make batteries from these cells. An individual lithium-ion cell has a nominal voltage of 3.7 volts. If it's fully charged, it's at 4.2, and if it's fully discharged, it's somewhere between 2.5 and 3. As with any voltage source, if you connect more than one together in series like this, then you'll combine their individual voltages into a single output voltage. Whereas if you combine them like this, you double the capacity, the amount of energy the system can deliver. So you can mix and match to meet your requirements. This 6-cell battery is 7.4 volts and 9 amp hours. And its configuration is often said to be 2S, 3P, 2 batteries in series, 3 batteries in parallel. There are some challenges in building performance systems with batteries like this. They arise mostly because it's not possible to make 2 cells which are the same. Here, for example, I've shown this cell as having slightly less capacity than the others. Each time the battery is charged, this rogue cell is overcharged and the one underneath it is undercharged. When the battery is under load, the rogue cell is over-discharged and the one underneath is under-discharged. This causes a progressive imbalance in the cells which leads to a combination of damage and underutilization of capacity. Balance charging is a way to greatly alleviate this problem. With conventional charging, the charge is connected to the positive and negative sides of the battery, and the cells inside are not seen. It's considered to be one homogeneous cell, but we know that's not true. Inside are a number of cells that are not all made equal. A balanced charger vastly improves on this because it has access to the intermediate points on the series circuit. It can't see individual cells in the parallel blocks. These are all connected together, and so these cells must be chosen to match as closely as possible, but it can see the connections between those blocks in the series circuit. Okay, now we can put it all together and see what a battery management system is. It's an electronic device with connections into the series circuits inside the battery, which allow it to charge and then balance charge all of the cells, so they're all restored to the same charge level at each charge. A BMS also protects against those dangerous outcomes we noted earlier. When the battery reaches its maximum charge level, the BMS will disconnect the charger. When the battery reaches its minimum safe charge level, the BMS will disconnect the load. And if for any reason the battery becomes dangerously hot, the BMS can sound the alarm. And finally, the BMS can limit the maximum current drawn from the battery to its specified safe levels. And now you're up to date on lithium-ion batteries and battery management systems.